So we're in section 5.2, and we're going to talk about verifying identities. So I'm not going to write down all these guidelines. I pass that little sheet out to you. I just want to go over them quickly. So what we're doing today is the only difference between what we're doing today and what we did yesterday is yesterday we were just simplifying our some kind of expression with trig functions. When we're verifying identities, basically they're giving us the answer. They're saying you can simplify this thing into this other thing. Show how you do it is really the point. So you know the answer, you know where you're going. So in one way, verifying identities is a little easier because you know what you want to get. You know where you want to end up. That's what we mean by verifying identities. And what we mean by identities is an identity is something that's true always. So it's going to be true for every x, for every theta, whatever. So we want to we're saying that these things are always true. So let me write down an example, and I want to go over these guidelines just in the context of this example. Well, what I'm going to do today is, like we did yesterday and like we did here for the homework, is I'm just going to go through a bunch of problems, and that's really how you're going to start figuring out how to do these. Is just see a bunch of these work, and you'll start recognizing different techniques. So let's look at, we want to verify, and that's what we do, that sine squared x minus 1 over sine squared x equals negative cotangent squared x. So when we're verifying identities, what the problem is asking us to do is show that I can get from I'm just going to show that I can get from here to here. This is my answer. I want to show that I can get the answer. So what our guidelines tell us, we're working on one side of the equation at a time. So we're not adding or subtracting from both sides of the equation. We don't divide on both sides of the equation. We don't know for sure that they're equal. We want to show that I can change this somehow into this. So I don't know going in that these two things are equal. I want to show how I can get from this to this. So we only work on one side of the equation at a time. And usually it's better to start with the more complicated side because that gives you more to work with. So that's your first guideline. We're only working one side of the equation at a time. Usually you pick the most complicated side because that gives you more opportunities to try things out. The second guideline says to look for opportunities to factor. So we practice on factoring. We did some examples. Add fractions, finding common denominators. So that's another common tool. So we square something. So if we have parentheses, we can FOIL that thing to come up with something else. Or find a common denominator. So that's our second guideline. So using the algebra tools that we talked about yesterday. Our third guideline is look for ways that you can use the identities, the list of identities that we have. So figure out what your answer, what your final expression, what it is in terms of, and look for identities that involve sine or cosine, whatever you're trying to get to, and see how those might help you. Often sines and cosines go together well. Secant and tangent go together well because of how they're related. And cosecant and cotangent. When we see things that are squared, like I said yesterday, we're looking for opportunities to use those Pythagorean identities. They say as a last resort, convert everything to sines and cosines. I often do that not as a last resort, but often it's a useful tool where we can rewrite everything in terms of sine and cosine. So that's another thing another way that we can go about verifying identities. And the last guideline is always try something. If you try something, that might give you a hint as to how you want to do this. So let's take, again, today I'm going to just go through a bunch of examples of how I work these identities, showing how we can get from one thing to another thing. So on this one, I'm going to work on the left side. It's the most complicated side. Gives me more places to work. So I see the sine squared x minus 1. That makes me think of the Pythagorean identities. So I know that, and I'm just going to write what I'm using here. Sine squared x plus cosine squared x equals 1. So if I subtract 1 from both sides, sine squared x minus 1, and I subtract cosine squared from the other side, I get sine squared x minus 1 equals minus cosine squared x. So that's just moving around the Pythagorean identity for sine squared and cosine squared. Well, here in the denominator I have a sine squared x minus 1. So I'm going to substitute minus cosine squared x over sine squared x. And from our definition of the cotangent, this is just minus cotangent squared x. So that one was an easy one. And often on these identities, there are lots of different ways that you can do this. I can work this identity in lots of different ways. This I just think is the quickest and easiest. But the idea here is I showed that I could turn this into this. I can get from here to here. So that's how we verify that identity. That I change this into this. Questions on that one? So that one was pretty quick and easy. So let's look at another one. So I want to verify. On these, we're verifying all of these. 1 over secant x minus 1 minus 1 over secant x plus 1 equals 2 cotangent squared x. So I want to show that I can get from here to here. I'm going to work the left side because it's the most complicated. So what am I going to want to do to this left-hand side? How can I simplify it? Here? That's subtraction, yes. Minus. So what can I do to simplify that left side? I can combine them. I can subtract those fractions. So to subtract those fractions, what do I need to do? Right, so I have to find a common denominator. So I'm going to move this over a little bit just so I can write mine. I'm going to multiply this part by secant x plus 1 over secant x plus 1. And I'm going to multiply, I'll move my minus sign over here. And I'm going to multiply this side by, put it in red, secant x minus 1 times secant x minus 1. That's going to be my common denominator. And I'm going to put parentheses here to remind me that I have to multiply these out. So in the numerator, I end up with secant x plus 1 minus secant x minus 1 over, and when I multiply these out, I get secant x plus 1 times secant x minus 1. When I multiply those out, I get secant squared x minus 1. My first, if I FOIL this out, first is secant squared, the outside is plus secant x, the inside is minus secant x, and the last is minus 1. Well, the numerator simplifies to what? What do I end up with here in the numerator? Two. Secant x minus secant x is 0. 1 minus negative 1 is 2. And I get 2 over secant squared x minus 1. And if I look at my Pythagorean identities, I have an identity for tangent squared and secant squared. Secant squared x minus 1 is just tangent squared x. So I get 2 over tangent squared x, which is the same as 2 cotangent squared x. So I showed that I could get from this to this. So I verified that identity. Questions on that one? Yes?
So how did you go from secant squared x minus 1 to tan?
I have on the upper right side, on my identity sheet, I have an identity that says tangent squared x plus 1 equals secant squared x.
Oh, yeah.
And if I subtract 1 from both sides, then I end up with that. Okay? So anytime you see a trig function squared and a plus or minus 1, that should be a hint that maybe it has something to do with the Pythagorean identity. So this one, even though we had to get this common denominator, this one wasn't too bad. Any other questions on that one? All right, let's look at another one. So we're verifying still 1 plus cotangent squared x times 1 minus sine squared x, and we want to show that that is cotangent squared x. So we want to verify this. So I'm going to work the left side. It's the most complicated. Anybody have some suggestions about what we can do? What do each of these parentheses make you think? What should we be thinking when we see those? Pythagorean identities. So look on the right side of your sheet. Do we have a Pythagorean identity for cotangent squared? 1 plus cotangent squared is what? So I can rewrite this as cosecant squared x. 1 minus sine squared x is just cosine squared. I just subtract the sine squared from both sides. So this would be cosine squared x. So I just rewrote this. Now I'm just going to rewrite these. Cosecant squared is 1 over sine squared x times cosine squared x. So I'm just rewriting this in terms of sine of x. And cosine squared over sine squared is cotangent squared x. So again, Pythagorean identities, and then simplify. Questions on that one? Now we could also, it would work if you FOILed this and simplified. You could FOIL these parentheses and simplify from there, and you would get the same answer. I think that would take a lot more work, but it is possible. You can do it that way. A lot of times there are lots and lots of different ways to do these to get from one place to the other. And it really depends on the way you pick and what different identities you use, how easy or how hard or how quick it's going to happen. All right, let's look at another one. So this one, we have secant u plus tangent u equals 1 over secant u minus tangent u. So this one, it's hard to tell which side is the more complicated side. So this one, really, you could take your pick on as to which side you want to use. So we can do it either way. What would you guys like to do? Want to work the left? Okay. Because so on the left side we don't have any fractions. So that might make it easier. So let's work the left. All right, so to work the left, what are we going to want to do? So yeah, let's rewrite these in terms of their reciprocals and their quotients. So this is 1 over cosine u plus sine u over cosine u. Now what do we have to do? What are we going to do from here? Combine them? So this is 1 plus sine u over cosine u. Kind of doesn't really get us where we want to go, does it? Anybody have, we talked about one thing that we could do, do with something like this from yesterday. Any ideas? My guess is we could multiply this, the top and the bottom, by 1 minus sine u over 1 minus sine u. So I said sometimes when you have something like this, we can think of it as multiplying by the conjugate, kind of like imaginary numbers multiplying by the conjugate. So when and I'm not sure this is going to work. I'm following along with what you guys said. I think it will. It looks like it will to me. So when I FOIL this out, I get 1 for my outside I get minus sine u, for the inside I get plus sine u, and for the last I get minus sine squared u. So I end up with 1 minus sine squared u over, and when I distribute here I get cosine u minus sine u times cosine u. So I think we're getting to where we want to go. 1 minus sine squared u is what? Cosine squared. Cosine squared u over cosine u minus sine u cosine u. All right. Anybody have an idea what we want to do here? Get rid of one of the cosine u's. I have a common factor here, so I'm going to write this as cosine squared u. I shouldn't have distributed here. It would be easier if I hadn't distributed. Cosine u times 1 minus sine u. So I just factored out a cosine u. One of these cancels. One of the cosine u's cancels. So I get cosine u over 1 minus sine u. And then I can, let's see, does this help me? I'm not sure this helps me. I think we might have hit a dead end here. So this is, we might be able to keep working with this. So when we work with the left side, this is an example of working with something and then not really getting where we want to go. So sometimes this happens. I'm not sure. I think we could do something with this, but I'm not sure where we would go from here. Off the top of my head, I'm not sure where we would go from here. So let's look at this, and let's work, instead of working the left side, let's work the right side. So we got here. I'm not sure this is going to lead me where I want to go. So let's turn around and work the right side. And sometimes that happens with these trig identities. So let's work the right side. So I have 1 over secant u minus tangent u. So I'm just going to say here, question mark. I'm not sure where to go from here. I think we could do something, but I'm not sure what. So work the right side. What can we do to work the right side of this? Any ideas? We can't just put this as 1 over secant and 1 over tangent, so we can't break up the fraction that way. So what I'm going to suggest is let's write everything in terms of sines and cosines. So I'm going to say this is 1 over cosine u minus sine u over cosine u. And now we need to add this fraction. So how are we going to, what do we do from here? This is 1 over 1 minus sine u over cosine u. Oh look, we end up at the same place that we ended up before. 1 over sine u, 1 over 1 minus sine u over cosine u is cosine u over 1 minus sine u. So we ended up at the same place. So now we need to keep going from here. So I'm going to do what I did. I'm going to do what I did here, and let's multiply by 1 plus sine u times 1 plus sine u. So when I multiply this out, I get this is cosine u times 1 plus sine u over, and when I FOIL this out, I end up with 1 minus sine squared u. My first is 1, outside is sine u, inside is minus sine u, and minus sine squared u. 1 minus sine squared u is cosine squared u. So I get the cosine of u over, or times 1 plus sine u over cosine squared u. I can cancel one of these cosines. This is 1 plus sine u over cosine u. And now I got to where I wanted to go. I can split this into two fractions. This is 1 over cosine u plus 1 over, or sorry, sine u over cosine u. And that equals secant u plus tangent u. And that's where we were trying to get. We worked the right side, and we showed that we could get to the left side. Yes. I just split this into two fractions. So cosine u is my common denominator here. So my common denominator is cosine u, so I can turn this into two fractions. All right, so that one was long. We ended up hitting a dead end, and we had to figure out how to undo our dead end. So that can sometimes happen. Let's see. I just want to do one more. This one won't be as long. One last example. Let's verify the cotangent squared of theta over 1 plus cosecant theta. Let's verify that that's 1 minus sine theta over sine theta. So I'm going to, we could pick either side. I like the fact that this side has a cotangent squared, so I'm going to pick the left side. Let's work the left. From our Pythagorean identities, we have a Pythagorean identity that involves the cotangent. If I look at that third Pythagorean identity, I know that cotangent squared of u is cosecant squared of u minus 1. So I'm going to rewrite this as cosecant squared of theta minus 1. And this is over 1 plus cosecant theta. And now on this one, I'm going to factor. This looks like the example that we did from our homework, where we have a quadratic in the numerator and something that involves one of the terms in the denominator. So I'm going to look at this and say, if I factor this numerator, maybe I can cancel this 1 plus cosecant theta. So how can I factor cosecant squared theta minus 1? Cosecant theta plus 1 times cosecant theta minus 1. So I'm factoring the numerator. So I'm just going to put a note here that I factored. So I factored the numerator. And now I can cancel this cosecant theta plus 1. So that cancels. And I end up with cosecant theta minus 1. And cosecant theta is 1 over sine theta minus 1. And now to combine these into one fraction, I need a common denominator. So my common denominator is sine theta. So this is 1 over sine theta minus sine theta over sine theta. I'm just finding a common denominator to combine these two. And that finally equals 1 minus sine theta over sine theta. So this one we factored and canceled a term. So again, lots of different ways we can do these. Lots of different ways that to get to the same answer. Sometimes you run into a dead end. Sometimes that dead end might give you a hint as to how we need to move forward. But the idea is try something. If that doesn't work, try something else. And the only way to get better at these is to keep trying. All right, homework for today. Very similar to what we did last night, just now you have an answer to work towards. All right, there you go.